All right, everyone, this is the explanation video for predicting products. So now here is the reminder of our types of chemical reactions. We have synthesis, decomposition, single replacement, double replacement, and combustion. So now, one thing with predicting products is that I'm not going to ask you about decomposition because there's no real way to predict how a compound is going to split up into its two different parts. However, synthesis, single replacement, double replacement, and combustion have their clues that we can use. So, again, for synthesis, if we have a single element and a single element combining together, that's going to be synthesis and it's going to create a compound. If we have a single element with a compound, that's going to be single replacement. If we have two compounds, we have double replacement. And for combustion, this one's the easiest one because we're looking for that O2 in the reactant side, and then we're always going to make H2O plus CO2. So automatically, the products are these two right here. Okay, so let's take a look at our first example. So first, always ask yourself, is this combustion? If not, then we can look at the other three. So let's look at the first one. So is this combustion? All right, if you said yes, this is correct because we have this O2 right here. So reactant type, this is combustion. Okay, and then potential products. So I'll show you how this is different in the other ones, but for now, our products are going to be automatically which ones? H2O and CO2. Okay. And then balance charges, we don't need to balance charges for H2O and CO2. Everything is already done for you, so we can just either disregard or write it again. But this is only for combustion. Okay, balanced equation, we're going to skip that for now. I'm going to predict only the products. And then at the very end, I'm going to balance, actually, I'm going to balance this one, number one, for you. Okay, so let's get started with the next one. Now, is this combustion? So we don't have O2 by itself on the reactant side, so this is not combustion. Let's take a look at the next one. So is this synthesis? Do we have a single element plus a single element? Well, CS, we have a capital C, lowercase s, so this is one element, right? But then we have capital H and capital S. These are two different elements. This is a compound. So we have a single element with a compound. This is going to be single replacement. Okay. So what's going to happen is that we need to identify what are the charges of each of these. Okay. So by charges, I mean, if we look at right here on your practice problem sheet, you will have this periodic table, but the easiest way to learn the charges is that, well, if group one has one valence electron, right? If it loses that electron, we're losing one negative, it's going to become a positive. Now, in group two, no. In group two, they have two valence electrons. So if it loses two, right, we're losing two negatives, those elements become plus two. All right, and so on and so forth. So 3 becomes plus 3, 4 becomes plus 4, and then once we get to 5 valence electrons, so N has 1, 2, 3, 4, 5. Now, group 5 is going to actually want to take electrons in order to get its octet. So in order to have a complete octet. So that means it's going to gain 3 negatives. So if we gain 3 negatives, it's going to be -3. And then over here, oxygen or group 16, right? Group 16 is going to have 1, 2, 3, 4, 5, 6. It's only going to gain 1, 2 electrons. So it's going to be -2 or 2 negative. And so on. 17 only gets 1 electron, so it's going to be 1 negative. So that's how we get, and that's how you can easily remember the charges. But you also have this sheet right here. Okay, so let's go back. Our single element right here is CS, so let's go ahead and look for CS. CS we have right here in group 1, so its charge is going to be +1. Right now, I'm just going to say that it's positive. I'm going to leave the 1 for later. And so H, let's take a look. H is on the positive side, so I'm going to just say it's positive. And then S, let's take a look at S. S is over here, and it is on the negative side. So S is negative. Okay, so what's going to happen is that this positive, negative, giving them positives and negatives is going to tell us which one is going to switch with what. So the rule is that two positives cannot be together and two negatives cannot be together. So that means C and H, CS and H cannot come together. So what's going to happen is that CS and H are actually going to switch places. Okay, so for now, potential products, this is just putting the elements together, and later we're going to balance the charges. So H is going to end up by itself, and then we have CS, lowercase s, and then sulfur, capital S. Okay, so now when we're right here, that's when we start looking at the charges. So CS was +1, and sulfur is -2. Okay, so when we're balancing the charges, we're going to ask ourselves, are these the same value, right? Because if they're the same value, then we just leave it like that, as is. But 1 is not the same as 2, so these are different values. When we have different values, we are going to use the cross method. So we're going to take the number, and this 2 is now going to be the subscript for CS, and then this 1 is going to be the subscript for S. Okay, so then our balanced charges is going to be CS2 and then S1. So again, in chemistry, we don't write the 1, so I'm going to make this one invisible. Okay, and here is our compound. But we still have this H over here. So in your common ions sheet, you should see the elements that are diatomic, and you will see H right there in the box where it says diatomic. So diatomic means that if it ends up by itself, it ends up single, it actually ends up bonded with itself. So this is H2. In nature, we find H always bonded with itself. Okay. And this is going to be our products. So then eventually when you are balancing equations, you're going to put your reactants, which is CS plus H2S, reacts to combine to form H2 plus CS2S. And then from here, you work on balancing the equation. Okay, but I'll work on a balancing problem afterwards. All right, so the next one. Um, First ask yourself, is this combustion? We don't see an O2, so it's not combustion. So we're going to go to the next one, synthesis. Do we have an element by itself plus an element by itself? Well, right here I have an A and a line. So oftentimes students think that this is I for iodine, but A, if we look at the periodic table, we don't really have an element A by itself, right? We have Ag, or we also have this one right here, Al. It's always going to be aluminum. Okay, so A next to a line is always going to be aluminum. Okay, so we have aluminum and we have sulfur. So this is an element by itself and this is an element by itself. So this is synthesis. Okay, so then these two are just going to combine. Al, and then always put the metal first and then the non-metal second. So AlS. So then that's the potential product. Now we're going to determine the charges. So Al, if we look over here, it's in group 13, so it's going to lose its 3 valence electrons and become positive. So this is +3. And S is in group 16, so it's going to gain 2 electrons to become 2 negative, 2 minus. And 3 is not the same as 2, so these the values are not the same, so this means we're going to have to do the cross method. So the 2 becomes the subscript for aluminum, and then the 3 becomes the subscript for sulfur. So then we rewrite it. Our balanced charges is going to be Al2S3. Okay, and we have our third product predicted. So now I'm going to do number 4. Let's go ahead and take a look. So first ask yourself, is this combustion? We don't see an O2 by itself, so it's not combustion. Then we ask ourselves, is this, the next one is synthesis. Do we have a single element by itself? Well, we have K and then a line. So K, our element that is K by itself is potassium. So K and I, this is potassium and iodine. We don't have an element that exists that is Kl, so it's not Kl, it's Ki. So these are 2 different elements, Ki, and then we have Na and O. So we have 2 compounds. So 1, 2, 3, 4. What is that going to give us? This is usually what tells us the difference between single replacement and double replacement. Single replacement, we have at least 1 element by itself, and double replacement, we have 2 compounds. So this is going to be double replacement. Because again, we have 2 compounds. K is with I and Na is with O. All right, now that we've identified that this is double replacement, don't mind my messy handwriting. Let's take a look at whether it's positive or negative. So K is on the positive side and then I is on the negative side. So K is positive, I is negative. And then Na, you can take a look, but it's on the positive side. And O is on the negative side. And which makes sense because the metal, the positive, is always first, and then the non-metal is always second. Okay. So again, the rule is 2 positives cannot be together and 2 negatives cannot be together. So we can't put K with Na and we can't put I with O, but we have to make a switch. So go ahead and switch the positives. So Na is going to switch out with K and K is going to switch out with Na. So when we write it out, Um, let's go ahead and start with Na ends up with I plus K ends up with O. Okay, so this is potential products because we're just putting them together. Now that we put the elements together, which ones go together? Now we can do the charges. So now we can actually add the numbers to it. So Na is +1, and then I is -1. Okay, so 1 and 1 are the same value, so we just leave it as NaI. That's our first compound. And now the second one, K is +1, and O, you can check it out, but it is -2. So 1 is not the same as 2, so we're going to use the cross method. So 2 becomes the subscript for K, and then 1 becomes the subscript for oxygen, right? So then we rewrite it, and that's going to be K2O. Technically is O1, but again, O's, we are ones, we write them as invisible. All right, and then the last one we have, so ask yourself, is this combustion? No, because there's no O2 on the reactant side. We have Li, which is lithium, and N, which is nitrogen. So we have two single elements. This is going to be synthesis. Okay, and we've already done a synthesis problem. So again, we put the elements together and then we determine what the charges are. So Li is +1, N should be -3. So again, these are not the same values. We are going to use the cross method. 3 becomes the subscript for Li, and 1 becomes the subscript for N. So our compound is Li3N. Okay, so this is how we determine the products. So remember, first determine what type of reaction. If it's combustion, automatically the products are H2O and CO2. And then anything else, so single replacement, just make sure that you are replacing the appropriate element so that we always have a positive with a negative. Synthesis, these just come together. And then we determine what the new subscripts are by determining the charges of each of the elements. So if the charges are the same, we leave it alone. But if they are different, different values, then we do the cross method by switching the values. Okay. And then again, double replacement, just making sure that we are changing the appropriate ones. Okay, so like I said, I'm going to go ahead and balance the first equation. So if you don't need balancing, you don't need to watch this part, but if you want a little bit of help with balancing, please stick around. Okay, so we have C5H12O2 plus O2 reacts to become H2O and CO2. So very first thing we do is divide our reaction in half, and then we list out our elements. We have C, we have H, and we have O. Okay, so right here, O is found both in this compound as well as this compound. So when I add it up, I am going to have a space plus the second compound equals my total. Okay, and same thing over here. I have C I have H, and I have O. And then O, again, I find it in two different compounds. So I'm going to spread that out. Blank plus blank equals total. All right, now I'm going to go ahead and start counting. So carbons, I have 5 carbons. I have 12 hydrogens, and I have 2 oxygens over here, and then 2 oxygens over here, so a total of 4. And then over here, I have 1 carbon. I have 2 hydrogens. I have 1 oxygen over here, and then I have 2 oxygens over here. And so I have a total of 3. Okay, so now oxygens, we often want to leave it till the end, and especially because O2 right here is by itself. So it's easier to change the amount of only oxygens at the very end. Okay, so let's start with the first one, carbon. So over here we have 5, and over here we have 1. We always want to change the smaller value. So we are going to change the product side. So the only thing that we can change is the coefficient. So, and we have to multiply the coefficient with each and every subscript in the compound. So the number that I'm going to multiply with is going to be 5 because I want to get 5 carbons. So carbon, I'm going to have 5 now. So actually, I'm going to make it in a different color, right here, 5. So I now have 5 carbons, but I'm not only changing the amount of carbons I have, but I'm also changing the amount of oxygens that I have. So instead of 2 oxygens, I now have 2 times 5, which is 10. So technically, now I have 11 oxygens. Okay, so carbons are now balanced. Now we have the hydrogens. So I have 12 over here and I have 2 over here. So again, I'm always going to change the smaller side. So I'm going to change the products. So what number can I multiply to get to 12? Well, I have this 2, so it's I need 2 times something is going to give me 12, and that's going to be the number 6. So 6 times 2 is going to give me 12. But again, I'm not only changing the hydrogens, I'm also changing the oxygen. So that's going to be 6 times, and remember, if we don't have a number, it's an invisible 1. So this is going to be 6 times 1. And I'm going to have 6 new oxygen. Okay. So now my new total for oxygens is going to be 6 plus 10 is now going to be 16. Okay, so let's look back. My carbons are good. My hydrogens are good. Now the last one that I need is oxygen. So now I have 2 from the first one, and I just need to change this one right here. So I need to see how many oxygens I need to add on this side. Okay, so to get to 16, I need 2 plus blank is going to equal 16. So that's going to be 14. So the number that I need to get to is 14. So what times 2 is going to give me 14? 7. So 7 times 2 is 14. And then my other 2 from the first compound, so 2 plus 4 is going to give me a total of 16. Okay, so the last thing that I do is any empty space, I fill it with a 1. And these are now my coefficients. I have 1 C5H12O2. I have 7 O2s. I have 6 H2Os, and I have 5 CO2s. And this is now our balanced equation. So you will need to do the balancing on a separate sheet of paper. But what I want you to do is please do all of the predicting products first and then go back and balance as many as you can. Okay, that is the end of the video.